In this question, we're told that there are only n red balls and n plus 1 blue balls in a bag. Shamsa takes 2 random balls from the bag. Show that the probability that both balls are the same colour and that probability is n over 2n plus 1. So, first thing we need to do is we need to work out the total number of balls in the bag. And all we can do from this is to say that there are n plus 1, which is 2n plus 1. So in total, there are 2n plus 1 balls in the bag. Now, whenever we've got two events taking place, a common starting point would be to do a tree diagram, and that's what we're going to do now, okay? So as we do this, I can see that the probability, so let's have the top as red, and that's going to be blue, so red and blue, red and blue. So the probability of, on the first attempt, getting a red ball is going to be n over 2n plus 1. Probability of getting a blue ball is going to be n plus 1 over 2n plus 1. Second time round, now in this top strand, of course, they've already taken a red ball out, so there's now n minus 1 red balls, and there's also one fewer ball, so there's only that many balls left, okay? So what we're doing here is, it's the same that we would do if there were numbers, but because we're dealing with algebraic expressions, we've just got to be that little bit more careful to make sure we don't make a silly mistake. So, the probability of getting a blue on the second time, well, we've not had a blue so far, so there is still n plus 1, but we've got one fewer balls, so it's going to be 2n. Looking down to the bottom fork, if I've taken a blue ball, then I've still got n red balls, but that's going to be one fewer again, so it's going to be 2n. And if I've already taken a blue ball, then I've got one less than n plus 1, which is n, and I've got one fewer ball, so that's that, okay? The question talks about both balls being the same, so I'm looking at this option or this option, okay? So if I first of all try to work out the probability of getting both reds, so that of course is going to be n over 2n add 1 multiplied by n minus 1 over 2n. If I multiply that out, I get n brackets n minus 1 over 2n brackets 2n add 1. Just swap those around to make it a little bit easier to see. So from there we get n squared minus n over 4n squared plus 2n. If I look at the blue option now, I'll do the blue option down to the left. So I've got n plus 1 over 2n plus 1 multiplied by n over 2n. So again, some of these are going to be the same, so we're going to have, I was just checking and I'd got a subtract at the top, which I had. So we're going to have n brackets n plus 1 over 2n brackets 2n plus 1, which when we simplify that out again, we will get n squared plus n over 4n squared plus 2n. Of course, what we need to do now is we need to add these together because both of those different roots will give us the correct answer. So I need to say that it's n squared minus n add n squared plus n over 4n squared plus 2n. Of course, you can see where these different bits are from. This goes to here, and this goes back to here, okay? Just rub those out because they're a bit messy. So, what we need to do now is simplify it. And as I simplify it, I get that I've got 2n squared minus n plus n, or negative n plus n, cancels out. So it's 2n squared over 4n squared plus 2n. Now at this point, you could be very tempted to say, hang on, this hasn't worked. But if you look at this expression, you can see that we can factorize it. There's an n in each of them, and they're also even numbers. So I know that I can pull out 2n from each of these terms. 2n times n is 2n squared over 2n lots of 2n to make the 4n squared and 1 to make 2n. At that point, all I need to do is cancel the common factor, and I am left with, right in the corner, n over 2n plus 1. So I've proven that that question is correct, and that the probability of getting two balls the same colour is n over 2n plus 1. Okay? So quite a lot of steps in that, and it's made more confusing potentially by the fact that you've not got numbers, you've just got algebraic expressions. But if you trust yourself and you trust that you know how to deal with these, then it should be possible for you to work through and get to the right answer. Okay? Okay, that's it for now. Thank you for listening, and I'll see you again soon. Bye-bye.